The first thing I want to do is just go over a quick explanation of what the difference is between a definite integral and an indefinite integral. An indefinite integral is going to be when you take the integral and you don't have any boundaries. And it's just going to look like this. While a definite integral, which is what we're going to talk about today, is going to have boundaries. It's going to have, like, let's say from, you got this function and you want to know what's going on from where x is 2, well, we'll say 8 just to make it, so where x is 8, of f of x dx. And I'm going to show you in a little while how you solve that. So take this graph. And I don't know, I'm just going to do some squiggly line, right? I'm going to say, okay, there's this whole area under this curve that we've been talking about. And that's got to do with the integral and the Riemann sums. And what you're going to do now is say, okay, well, definite integral says what is the area from where x equals 2, let's say, to where x equals 8. So we're going to be just concerned with the area under this curve here and not the rest. And that's the difference between a definite integral, and it's called a definite integral because you get a definite number for it. You get something for it. So let's get to the properties of definite integrals. All right, I had to take off the first title because I didn't put definite. So I just want to make sure you know we're dealing with definite integrals. And I'm just going to give some different examples. Let's say I ask, okay, the integral from a to b of f of x dx is going to equal the opposite of the integral from b to a of f of x dx. So if I tell you, let's say, integral from 3 to 1 of f of x dx is equal to 7, let's just say. Then if I tell you that, then you know that if I said, well, what is the integral from 1 to 3 of f of x dx? And that would be -7. That's just one of the properties. Another property is if you take the integral from, let's say, 2 to 2, if the number is the same, your boundaries are the same number of f of x dx, and that's like saying, all right, I take the integral, I plug in 2 from what I get, minus the integral, and I plug in 2 again from that. And this capital F means the answer from what your integral is. That's why it goes capital. And anything minus itself, because you're going to get the same answer, is 0. So if they want the limits to be the same, then you're just going to get 0 for an answer. And another property is the integral, the definite integral of a constant. So if you have the definite integral of a constant c, from a to b, of just, well, I'll say k, because I've seen some use k. That's going to equal whatever k is, times whatever this upper limit right here, the upper limit minus the lower limit. So it's going to be a times b minus a. For example, if I said, what is the integral from from 1 to 5 of 3 dx? Well, that's just going to equal k. So it's going to equal 3 times your upper limit, which is 5, take away the lower limit. And then that would just give me 5 minus 1, so that's 12. So you want to memorize that. Anytime you see just a constant, and it's a definite integral, it's going to be whatever that constant is times the upper minus the lower limit. And that kind of makes sense if you think about it, because you have this graph and the integral is the area, right, under the graph. And here your f of x is 3. So let me get a different color. Let's see. Go with. All right, so let's say f of x is 3. So you're here, let's say, 0, 1, 2, 3. And then you've got this right here, this graph, where f of x is equal to 3. Or y equals 3. Think of it that way. Y equals 3. And then you got, you want to know what the area is from where x is 1 to where x is 5. So we're looking here at this area. So you've got this box, this rectangle. Just look at it. It's going to make a rectangle. And you're looking at this area here. And you're saying, okay, well, from here to here, we know that's 3. And this distance is 5 minus 1 is 4. And if you take the area of a rectangle, it's 4 times 3, so that equals 12. So that's how you get that property. Or that's how it makes sense. Another property is the constant property. So if I have the integral from a to b of some constant times f of x dx, and that's going to equal, you're just going to be able to pull it out. You can take the k out. I'll draw it just like it is. You can take the k out and then find the integral of f of x dx and their limits. And that is your answer. Now, if you have, let's say you have integral from 2 to 3 of f of x dx, and that equals 5, and this is a new property. And you have the integral from 3 to 5 of f of x dx, and that equals 8. These are basic common sense rules. I'm just telling you them so that you know that they are. Like your mind is like, does this work? And pretty much the answer is always going to be yes. So this is from 2 to 3, and this is from 3 to 5. So this rule here says that the integral from 2 to 5 of f of x dx is going to equal, well, let me just show you. You're going to add them. So I'm going to show you in a quick graph. Let's say I have this random graph. And if I tell you that from 2 to 3, you know, the integral means the area under that curve. So if this area under this curve is equal to 5, and then now I'm going to go from 3 to 5, and I'm going to tell you this area, although this doesn't look like, I'll make it longer so it looks more realistic. So from 3 to 5, which it really doesn't because 2 to 3 and 3 to 5 don't match up, but let's just say this area from 3 to 5 is 8. If I wanted to know the area of the whole thing, I would just say, okay, it's this area plus this area. And that's where you get the answer, or at least this property. You add it up. That would be 13. So there's another rule that looks like this, but it's not the same. And this is called the integral of a sum rule. And it's going to say that if you have the integral from a to b of f of x plus g of x dx, then you can just break it up. It's kind of like our derivatives. It'll be the integral from a to b of f of x dx plus the integral from a to b of g of x dx. And there's a difference rule. So you can have this as the sum or difference rule, because if I have this and I'm minusing, the same rule applies. If I'm saying f of x minus g of x dx, I could break it up into f of x dx minus g of x dx. Let's see, how many other properties? We got some more properties. Let me just go through. If you have a graph that is above the y-axis, then your integral will be positive. And if you have an graph that is below the x-axis, I'm sorry, below the x-axis. So your y's are all negative, then your integral should be a negative integral. And if you have a graph that is above and below, then you're going to take the area above minus the area below. Or minus this, so it'll be above minus below. All right, so there's just a little more time. Let me go over some examples. If I say, what is the integral from 0 to 2 of x squared plus 1 dx? Well, that means you're going to break this up and find the integral of each. So I'm going to start out here, and I'm going to do that first. The integral, I add 1, and then I put it over that. Whatever I get, I put over it. So I got 3, I put it over 3. So with 1, well, you know the integral of a constant You could treat that like x to the 0 if it makes you feel like you understand it better. Add 1 over 1. So you'll have x, because it'll be from the x to the 0 power to x to the first power. And then notation here is from at this point, it says you're going to go ahead and evaluate it from those 2 points. So that'll be your answer is a capital F. So you're going to say, first, you're going to evaluate from f of 0. I'm sorry, f of 2. Minus f of 1. Or f of 0. So you do the upper boundary minus the lower boundary, and that's going to say, okay, well, f of 2, I'm going to plug it in here. So that's going to be 2 to the 3rd over 3 minus 0. So that's equal to this is messy. Hold on. Let me fix this. Start over. Hold on. Okay, so this is what we had. We're going to evaluate this right here. From 0 to 2. So first we got to do the upper boundary first. So it's going to be f of 2 that we're going to do first. So to get that, I'm going to come in here and I'm going to put 2 to the 3rd over 3 plus 2. I'm doing just the upper boundary right now. So that would be equal to 8/3 plus, let's make this 6/3. It's 2 6/3 so that I can add them easily, and that will give me 14/3. So far I've got this part. Now I got to take away the lower boundary, which in this case is going to be pretty easy, thank goodness. It's going to be 0 over 3 plus 0. So that's going to give you minus 0. So your answer really is just going to be 14/3. All right, so let's say I have this example. The integral from 1 to 4 of 2x plus square root of x dx. And in this case, you want to change this into a fraction. And then you want to go ahead and break it up. So I'm going to go ahead and find first integral from 1 to 4 of 2x dx. And then I'm going to come over here and I'm going to find the integral, because I'm breaking it up, of x to the 1/2 dx. So if I find first the integral of 2x dx, that's going to equal, well, take out the 2 and just work with the x. That gives me x squared. So I'll get x squared over 2